Hi, this is Mrs. Bolin with your notes for section 6.2. Today we're going to talk about parallel and perpendicular lines. So first, as a warm-up, we are going to find the slope. And so remember, we first originally learned this on a graph where we are counting how far up or down and how far over. There is a formula for it, and it looks like this. The slope is equal to y2 minus y1 over x2 minus x1. Now it looks kind of confusing, but here's what it means. We know that these points go alphabetically. Here's an X and here's a Y. Well, this is the first point, so we put a little 1. And then this is the second point, so we put a little 2. So all this really means is I'm going to see how far did it go up or down. And the way that we find that distance is by subtracting those values. So if you know, oh, from 3 to -1, it dropped by 4, you can just write -4 on the top. But you could also plug it into the equation. So the second y value was -1. The equation has a subtract sign in it because anytime we're finding the distance from one place to another, we subtract to find how far it traveled. And so we're going to subtract the first y value, which was 3. Then on this one, I'm going to look for the second x value, which is -6, and I'm going to subtract the first x value. So I have -5, so minus a -5. Remember that anytime we subtract a negative, that's the same thing as adding a positive. So -1 and -3, it makes -4. And then if I have -6 but a +5, remember that's like having 6 negatives, 1, 2, 3, 4, 5, 6, 5 positives, 4, 5. And every time I have a plus and a minus, they cancel. So I ask what's left over? I have -1. A negative divided by a negative is a positive, and 4 divided by 1 is just 4. So the slope for that one was +4. Again, you could have just said, well, we went down by 4 and we went backwards by 1. So -4 and -1, and then we get the +4 right there. This time, I'm going to use that information to actually write an equation. So if you notice, those are the same exact points, super nice. That way I don't have to redo all of the slope stuff. But the other piece that I need to write an equation is my y-intercept. And we don't have that. But what we do know is that y equals mx plus b. I already know m, and then I need to think, could I find an xy pair? Well, yeah, they gave us 2 of them to choose from. You could use either one. I'm just going to use the first one. I'm going to say, here's my x, here's my y. I'm going to plug it in. So for y, the value is 3. For m, the value is 4. For x, the value was -5. And then I'm trying to figure out what b is. So I'm going to simplify this. 4 times -5 is -20. So I'm going to add that to both sides. So I get b is equal to 23. Now, it kind of feels like we're done because we solved for something, but don't forget we still have to plug it back in. So we get y is equal to m x plus b. And that is our final answer. And then question number 3 says, what does it mean for 2 lines to be parallel? We'll remember from, I think it was like unit 2, we said that parallel lines never intersect. So if one goes up and over, the second one goes up and over, and they're never going to cross. So you can just write that they don't cross. Question number 4, what does it mean for 2 lines to be perpendicular? And I'm just going to draw a little picture for each of those just to help you remember what they look like. Perpendicular means that they intersect at a 90-degree angle. So I'm going to say that they form a 90-degree angle. And the symbol that we use for 90 degrees is that little square. Okay, so if we are talking now about linear functions, and we're talking about parallel lines, we know that parallel lines have the same slope. And if they have the same slope, they will never cross each other. Because if one goes up 2 over 1, the other one goes up 2 over 1, and they'll never get any closer to each other. So parallel lines, underline, put a box around same slope. And then if any lines are vertical, they're all going to be parallel to each other. Or if they're horizontal, they'll all be parallel to each other. Most of the time, though, we'll have these kind of diagonal lines that we've been looking at. Perpendicular lines form right angles. So perpendicular lines their slopes are going to be opposite reciprocals. And what that means is opposite refers to the sign. So one's going to be positive, one's going to be negative. They're going to be opposites. And reciprocal means that I flip the fraction. So if one was 3 over 4, the other would be 4 over 3. But one would be positive, one would be negative. So they're opposite reciprocals of each other. So we're going to go ahead and do some problems. And then if we need to, we'll refer back to the notes. But we're going to go ahead and go on to our practice. So this one says determine which of the lines, if any, are parallel or perpendicular and explain. So I'm going to find the slope of each one. So you can kind of see here, this one has a little a by it. So I'm going to find the slope of line A. I'm going to find the slope of line B. And I'm going to find the slope of line C. So for line A, I went up by 3 over by 1. And it was positive, so I want to fill that in there as positive. For slope B, I went down by 1 over by 3. For slope C, I went, it doesn't cross again until I get to that point, so I went up by 5 over by 2. Okay, so if I want to know if any are parallel, I'm going to say, are any exactly the same? So look at those three, A, B, and C. Are any of those exactly the same? No. So parallel would be none. Perpendicular would be any one that I flipped over the fraction, one's positive, one's negative. Okay, so are you guys looking? Do you guys see which ones it is? So if you thought A and B, you would be absolutely correct. And you could write it like this. A is perpendicular to B. All right, and you don't have to write every time the labels parallel, perpendicular. If it's none, you don't have to write none. They're just asking, look at all these lines and are any of them related in this way, parallel or perpendicular? So you could just say A is perpendicular to B. That would be your final answer. Okay, so looking at problem 2, we're going to do the same thing, but instead of counting up and over on the graph, we're going to solve for it. Remember that I'm going to find the slope of A, which would be y2 minus y1. So 2 minus negative 1, and then x2 minus x1. So 2 minus negative 4. And so anytime I have minus a negative, that's the same thing as add. So 3 over 6, if I reduce, is 1/2. Now I'm going to find the slope of B with the next points. So I'm going to go 1 minus negative 3, and then I'm going to go 5 minus negative 5. So anytime we have minus negative, it's adding. So I have 4 over 10, which if I reduce it, we get 2 over 5. And then I'm going to do the same thing for C. The slope of C would be negative 1 minus negative 3 and 2 minus negative 2. So I have positive 2 over 4, which would be 1/2. So now the question is, are any of them parallel or any of them perpendicular? In order to be parallel, they would have to have the same slope. So I do have 2 lines with the same slope. So I know that A is parallel to C. Now I want to check for perpendicular. Do any of them have slopes that are flipped over and opposite signs, 1 plus, 1 minus? The answer to that would be no. So for this one, we just know about our parallel lines. Okay, question number 3. We are going to be writing equations with some given information. And again, also on these ones, you guys, if you just say from negative 1, I went to 2, how far did I go up by? I went up by 3. If I started at negative 4 and I traveled all the way over to positive 2, I went a distance of 6. So you can either use the formula or just ask yourself, how far did I go up or down? How far did I go over? All right, question number 3. We have a point that the line passes through, and we know that it is parallel to this line. So if it's parallel, that means the slope has to be the same. So we know that m equals 2. We do not need any other information from that equation. It does not apply to our situation. All we get from this is that the slope is the same. Now I have an m I have an x and a y. I really need b, but I don't know that. And so we're just going to have to plug in what we know to y equals mx plus b until we get the m and the b. We already have the m. So y is -3, m is 2, x is 5, and then plus b is what I'm trying to find. So -3 equals 10 plus b. I need to take away the 10, so -13 equals b. And then I'm going to plug in and find my answer. So my answer is the equation, right? Write an equation. That's the instructions. So y equals 2x minus 13 is my final answer. All right, let's try another one of those. Okay, again, parallel means that the slope is the same. So if the slope is the same as this line, that's the only piece of information I need from this equation. You can ignore the rest. I know that m has to equal 1/4, because if the lines are parallel and never cross, they have to move in the exact same way. Okay, so now I'm going to plug it in. Again, this is x, this is y. So y equals mx plus b. The y value is 2. The m is 1/4. The x is -4, and then plus b. Remember that a fraction is just like having a division problem and a multiplication problem. Well, the times by 1, that's easy. It doesn't change it. I'm just dividing by 4 is what I'm doing. So what is 4 divided by 4? 1. And then if I have a positive times a negative, that just gives me -1. And then I need to add the 1 on both sides, so b is equal to 3. So my final answer then is y equals mx plus b. And I plugged in my value for, oops, see, that's why I shouldn't talk and write at the same time. I plugged in my value for m. I plugged in my value for b. That would be a 1/4. I have no idea why I wrote it 2. All right, question number 5 on our practice. Now we're going to do the same thing, but we're going to do perpendicular. So remember, we don't need anything from this equation except for the slope. And the difference is that parallel was same slope. Perpendicular means opposite reciprocal. So this one's positive. That means my new slope will be negative. This one's 1/2, so I'm going to flip it over so I get 2/1. Okay, and we don't really need to write the 1 on the bottom. If it's just divide by 1, that whole thing is just -2. We want to simplify it if we can. So now I'm going to plug it in. This is an x, this is a y. So y equals mx plus b. The y value is 1, the m is -2, the x is -3, and then I need to find out what my start value is. So I'm going to multiply that. Negative times a negative is a positive. I'm going to minus the 6 on both sides. So I get -5 is equal to b. Again, my final answer is going to be y equals mx plus b. And remember that 1/2 we just used to flip it over, change the sign to get our new m. Then we don't use that anymore. We use the m that we found from it. Okay. Question number 6, we're going to do the same thing. This is the original slope. In order to find perpendicular, I need to change the sign. So it was negative, now it's positive. It was, if I had to write 3 as a fraction, I could write it 3/1. Well, now if I need to flip that over and find the reciprocal, that would be 1/3. So I changed the sign, negative to positive, and I flipped it over, 3/1, 1/3. So this is my slope, this is my point. We're going to plug it in, x and y, and we're going to find what our y-intercept is, our start value. So I know that y equals mx plus b, and I just need to look for the information. What's the y value they gave me? Well, they told me 5. The m that we found was 1/3. The x was -3, and then b is what I'm trying to find. Well, 1/3 of 3 is 1, or you can also think about this as 3 divided by 3, which is 1. And because this is negative, a positive times a negative is a negative, so 5 equals -1 plus b. When I add 1 on both sides, I get b is equal to 6. So y equals m. See, that's why I don't know why I always write it 2. Y equals mx plus b. Our M was 1/3, our B was 6, and that's our final answer. All right, I'm going to go ahead and go over the answers to the odd numbered problems, and hopefully I remember just to do the odds this time. You still have to do all the problems, but you should be trying the even problems on your own. So here we go. Question number 1. So this says determine which lines, if any, are parallel. And you can't just say, oh, those ones because they look parallel. You have to support it with some evidence. So we're going to say we want to find the slope of A. We want to find the slope of B. And we want to find the slope of C. And then we want to compare them. So all of them are negative. So you can go ahead and put the negative on there if you want. But this one went down by 5 over by 2. So that was letter A. Down by 5 over by 2. For letter B, I went down by 2 over by 1. And for this one, I went down by 2 over by 1. Okay, and so the way that we would say that is that because those two are exactly the same, we know that B is parallel to C. Okay, none of them would be perpendicular. Perpendicular would have opposite signs, and they would be reciprocals of each other. Question number 2. So now this one, we actually have to do the math. And again, you could just say for this first one, if I'm finding the slope of A, and I'm gonna say, well, how much did it go up by? It was at 3 and it went up to 9. So it went up by 6. What that would look like in the formula is 9 minus 3. Either way, you're gonna get a 6. If I went from -1 to 0 and all the way over to +1, I traveled over by 2. So that would be 3. For the next one, I'll go ahead and use the formula, but I just want you to know that where the formula comes from. We're just trying to figure out how far did we go up and how far did we go over, okay? So for the slope of line B, we started at 14 and we went over, or sorry, we started at 12, we went up to 14. So to find the distance, I could go 14 take away 12, and then I could go -1 minus -2. And I get 14 take away 12 is 2, -1 and a +2 makes a +1. So we just get 2 right there. And then for line C, we'll find the slope of that, and we'll go 10 take away 8 over 6 take away 3, and we get 2 over 3. Okay, well, those are all different. None of them are reciprocals or opposite reciprocals. So we would just say none. All the slopes are different. None of them are opposite reciprocals. All right, question number 3. We need to write an equation. Oh, guys, I just did an even problem. I just love doing problems. Sorry about that. Question number 3 is write an equation of a line that passes through the given point and is parallel to the given line. So we're going to plug this one in for our M, right? M equals -5. If it's parallel, we know that it has the same slope. We don't use anything else in that equation. We have an X value, a Y value. What we really need is a B, but if we plug those in, we can find it. So Y equals MX plus B. The Y value is 2, the M is -5, the X is 1, and we need to find B. So 2 equals -5 plus B. So all I have to do is add that 5 over to the other side. So B is equal to 7. So my final answer, Y equals M, which is -5, X plus B. Okay, I'm not going to fall for it this time. All right, you guys try number 4 on your own. Remember that when we have a fraction, you just really divide by the bottom number times by the top number. You could do it in either order. And you're going to be multiplying by this too, so those essentially kind of cancel out anyways when you get to your steps. You're going to do the same steps as this to find your final answer. All right, question number 5 says determine which of the lines, if any, are parallel or perpendicular. And so I'm going to find, let's see which one, this is C, this is B, here's A down here. So I'm going to find the slope of A, I'm going to find the slope of B, and I'm going to find the slope of C. So from A, I went down by 1 over by 3. For B, I went down by 1 over by 3. And for line C, I went up by 1, 2, 3, 4, 5 over by 2. So up by 5 over by 2. All right, so now I need to decide, are any parallel? Are any exactly the same? Well, yeah, A and B are exactly the same slopes. So I know that the lines are parallel to each other. And then if any are perpendicular, one would be positive, one would be negative, and then they would be reciprocals of each other. Well, that's not the case. So all we have is parallel lines. You guys are going to try this one on your own, just like problem number 2 that I accidentally worked out for you guys. Find the slope and then compare them to see are any parallel or any perpendicular. Okay, question 7. We're going to write an equation of a line that passes through the given point and is perpendicular to the given line. So perpendicular means that we are taking this slope and instead of just keeping it exactly the same like we did on this one, we just said -5, so slope's -5. That's if it's parallel. If it is perpendicular, we need to flip it over and change the sign. Okay, so M is going to be, this was positive, now it's going to be negative. 4 over 3 is going to be 3 over 4. And then I don't need anything else in that equation. I'm done with that equation. Now I just need this information they give me to find the value. So I'm going to plug it into y equals mx plus b, and I'm going to plug in the y, -1, m is -3/4, x is -4, and b is what I'm trying to find, okay? So if I go 4 divided by 4, that part just equals 1. And then I can just multiply straight across. So I have -1 equals -3 times -1. That negative's still there, even though we canceled the 4 and changed it to a 1. A negative times a negative is a positive, and 3 times 1 is just 3. And then I'm going to minus 3 on both sides, so b is equal to -4. So when I write my equation, that's y equals mx plus b. And because I'm adding a -4, I'm just going to write it as subtract 4. All right, you guys are going to try number 8 on your own. Be careful here, though, because this is the m that you're going to switch and flip over, right? This is like 2 over 1. We're always looking for whatever's stuck to the x when y is by itself. That's the slope. Question number 9 says, write an equation for the line that passes through this given point and is parallel to the line and is perpendicular to the line. So 2 separate problems. A is parallel, B is perpendicular. Well, first I need to find the line, and I want to find the slope of it. Okay, I went up by 3 and over by 1. So my slope is just 3. Okay, for this one, if I take the slope of this line, I have to do the opposite. So 3 over 1, and I need to flip it over and change the sign. So I'm going to have a -1 over 3. All right, so that's my new slope. This equals m. So this is if it was parallel to the line. This is if it's perpendicular to the line, right? A parallel, B perpendicular. Okay, then the other thing I need is just that point. I know that I have the point 3, -2 for both of those problems, 3, -2. So this is x, this is y, x, and y. So y equals mx plus b. We're going to plug it in. The y value is -2, the m is 3, the x is 3, plus b. So -2 equals 9. And I'm going to subtract the 9 on both sides. So I get -11 equals b. So for this one, y would equal, where's my slope? 3. 3x minus 11. So does that seem right? If I were all the way down here at -11 and I was going up by 3 over 1, would it be parallel to that and pass through that point? That looks pretty good. That looks like a good answer. So that's for part A. And then for part B, you're going to do the same thing, but with this fraction. So y equals mx plus b. So the y value is -2. The m is -1/3. The x is 3. And then plus b is what we're solving for. 1/3 of 3, those kind of cancel each other. Times by 3, divide by 3 are inverse operations. So really we're just left with that -1. So -2 equals -1 plus b. And I'm going to add 1 on both sides. So I get -1 equals b. So y equals m x plus b. And that is it. Sorry, that was so long, you guys. Good job for hanging in there. And that is your notes for section 6.2.